Hello, my name is Tobias Flitsch and I lead the product team at Nebulon. I'm here to talk about something that is on everyone's minds right now: ransomware. Ransomware is not only really expensive for organizations, it also takes a long time to recover from. But most worrisome is that ransomware is almost inevitable. A survey from Sophos shows that already a third of organizations were hit by ransomware in the last year, and experts predict that 3 in 4 companies will have suffered from an attack by 2025. So the question is, are you well prepared to recover from such an attack? We here at Nebulon have built very specific capabilities into our smart infrastructure solution that mitigates the risks associated with ransomware attacks and accelerate the time required for recovery. What you do during recovery is restore the operating system and application binaries, and then of course the application data. With today's options, this takes hours or more likely days. This is because the recovery of bare metal operating systems is super slow. Has to be done on many servers and probably multiple times because ransomware is often dormant for a while, so it's buried in backups. So for recovery, you may need to do this multiple times until you find a good backup. If you are using an external storage array, restore of application data is fast. But also here, you may need to do this in multiple iterations until you find a version that is not encrypted. With our new Nebulon TimeJump capability, we can bring the recovery time down from days to less than 4 minutes, both for the operating system and application data, allowing customers to recover much more quickly. We do this by use of our Services Processing Unit, or SPU, that is embedded in application servers in a separate fault domain and isolated security domain from the server. This means any ransomware that is running on the server can't encrypt the server's drives or compromise the storage layer. The SPU provides enterprise data services that protect the server's local operating system and any shared application data using immutable snapshots. That means you can instantly recover both the operating system and application data for an entire cluster at once with a simple push-button action, and all you really do is wait for servers rebooting into the recovered operating system, which is less than 4 minutes, so incredibly fast. Let's look at an example. What you're seeing here is a Microsoft SQL Server database with a table that I have populated with some example data. And as you can see, I can interact with the table and it's currently working fine. Now what backs this database is a 2-node Windows failover cluster. Here you can see the SQL Server role in the cluster. You can see its cluster name here, and that it's backed by a shared storage device that is served from the Nebulon data plane, which is where those service processing units I previously mentioned operate. You can also see that it's in fact a 2-node cluster comprised of 2 physical servers, Server 5 and Server 6. From a storage perspective, we can find 2 shared storage devices that are used by the cluster. There's the cluster disk that persists the data from our SQL Server, and there's another cluster disk that is used by failover cluster as a disk witness. This is the environment in a nutshell, but we're talking about ransomware today. What I've created is a tool that simulates an actual ransomware attack via full-scale encryption of data, but in a controlled manner where I know that it's not spreading in our lab. So let me kick this off. Ransomware is unpredictable because you can never be 100% sure what it will do. The one thing we know with ransomware is that it holds your data for ransom, usually by encrypting it, and the only way you can decrypt your data is by paying the ransom. In this case, ransomware is not only encrypting my application data on the E drive that backs the SQL Server instance, but it is also encrypting critical application binaries on the operating system. And you can already see its effects, where my profile is getting encrypted, causing the background to go dark. You can also see that I'm starting to lose the connection over remote desktop, so let me switch to ILO, the out-of-band management tool of the server, where we can see that there's severe damage already being done to one of the nodes. Now it's rather boring to watch my systems to get encrypted with ransomware, so I'll accelerate the video and stop at some interesting moments. It looks like at this point neither of the nodes are online anymore, as the database is no longer responding to any requests. And now we understand why. It's because both of our physical servers have crashed and are trying to reboot. Alright, I've let the systems run for a while, and if you paid attention to the screen, you saw multiple locations where the servers crashed and there were multiple reboots. The reality is that both of the servers are toast and it's now time to recover them. So let's start the clock and connect to Nebulon On, the control plane for smart infrastructure. What we are looking at here is the same Microsoft SQL Server cluster, just in a Nebulon web UI, where we can trigger the cluster restore. This is a simple 4-step procedure. We select the restore endpot action, pick a restore point, in this case I'll use the most recent one, click restore, and finally I confirm the action by entering the confirmation text. That's it. This kicks off the recovery procedure, and I can follow the process from the activities menu. But instead of just watching the bar reach 100%, let me explain a little bit more about what is going on and why this works. So both physical servers, in this case HPE servers, are equipped with a services processing unit. The services processing unit, or SPU in short, is a PCIe device that is embedded in the server, connects to the internal drives of the server, and then transforms their physical capacity into a storage pool with enterprise shared and local data services. These are then made available to the applications inside of the cluster. The key here is that the data services are not running on the server, but on that dedicated SPU, which is designed to be in a separate fault domain and an isolated security domain. This means there's no dependency on the server's CPU, memory, and network. So during these crashes that we've observed of the operating system, the data services were not impacted. This also means that applications on the server do not have direct access to the physical drives in the server and no way of encrypting them. They can only have access to data via the services processing unit by reading and writing to what we call virtual volumes. These are logical storage devices that are presented to the servers in the cluster. If we look at those, we will find 4 virtual volumes. There's the data volume, which we saw earlier in the failover cluster manager. This is the volume that is persisting Microsoft SQL Server data, and you can see that it is a shared volume that is accessible by both server 5 and server 6. We also have the volume that is used as a quorum disk, which is a little bit smaller, but also a shared device accessible by both servers. What is interesting though are these 2 additional volumes, one for server 5 and one for server 6. And as indicated by their name, these are for the operating systems of the servers. The operating systems are installed on those volumes. And like any other volume in the cluster, they are protected with erasure coding, mirroring, and we can apply our immutable snapshot capabilities to these volumes as well. The 3 recovery points that you saw earlier were created by standard snapshot schedules that are automatically set up by policy at the time the cluster is created. This makes sure that your complete system is protected and that there are plenty of restore points available. I can see that the recovery process is making progress and the servers are rebooting as part of this procedure where we first take a recovery point of the current state of the operating system in case something goes wrong, then restore all volumes to the selected point in time, and then reboot the server with the recovered operating system and application data. Alright, I think we are done and we can stop the clock at less than 4 minutes. Both servers seem to be online again, which means I can connect to them using remote desktop, just because it's easier than using the remote console. So let's connect to server 5 and then to server 6. Immediately you can see that there are no encrypted files on the desktop anymore. I can also open the failover cluster manager. And once it's started up, we can find that our cluster is up. The Microsoft SQL Server role with all of its resources is back online with the same configuration as before. And we can also see that both my cluster nodes are up and running. And if we navigate to the disks, we can find them available as well. One last thing to do, and that is reconnecting to the database to show that the connection is again established. And when I refresh, my data is accessible again. I just went through a complete cluster recovery from a ransomware attack on a physical, bare metal SQL Server cluster in less than 4 minutes. I am curious how you recover your physical infrastructure from ransomware today. So leave a comment below. And if you would like to know more about ways to recover from ransomware, contact your Nebulon solution architect or get in touch on our website at nebulon.com. Also, if you want to stay up to date with upcoming capabilities for ransomware protection, don't forget to subscribe to our channel. Thank you.